Hello, this is Chris Burrow presenting about sodium benzoate for analytical chemistry through Grand Canyon University. Sodium benzoate is the sodium salt of benzoic acid. It is formed by the neutralization of benzoic acid. Sodium benzoate is generally recognized as safe or a GRAS safe additive by the United States FDA. The structure of sodium benzoate is an aromatic ring with a carboxylic acid group attached, but with the proton replaced with a sodium. Sodium benzoate is water soluble and is hygroscopic at a relative humidity above 50%. The molecular weight is 144.11 with a melting point just above 300 degrees Celsius. There are several uses for sodium benzoate. Primarily, sodium benzoate is a preservative by its pH adjusting properties. It prevents microbes from growing. It does this by changing the internal pH of microorganisms to an acidic state that does not allow it to grow or survive. It does not kill bacteria or fungus already present, but it does inhibit their growth and reproduction. The preservative is used in foods, cosmetics, and other liquid medications. Other uses for sodium benzoate is helping with pill form medications to be swallowed more easily and to help them break down easily. It is sometimes used as a plastic strengthener and has industrial anti-corrosive applications. A last use and a more recent use for sodium benzoate, it's being studied more recently, is the remediation of soil which has been contaminated with heavy metals. Sodium benzoate works as a remediator by helping plants repair deficiencies in lipid and protein membranes caused by heavy metals. Heavy metals also stunt seed growth by affecting chlorophyll, germination rates, and root and shoot structures, again by causing damage to the membranes. Sodium benzoate can be used to help the plants with all of these structures. Sodium benzoate is not particularly harmful to the environment, and it is added to the atmosphere, watersheds, and sewer treatment plants through industrial release. Humans release sodium benzoate into the atmosphere because of the release of the preservatives in foods and cosmetics. Bioaccumulation and geoaccumulation is not observed. Toxicological effects with sodium benzoate are minor when in small amounts. Of course, in large amounts, it could damage the liver. When in the presence of ascorbic acid, which is vitamin C, sodium benzoate could produce benzene, which is toxic to humans. There have been several studies recently, especially with sodas, where there is vitamin C added along with sodium benzoate as the preservative. And in the last few years, there have been a few sodas that have been taken off the shelf due to possibly benzene poisoning. Other possible side effects are inflammation, attention deficit hyperactivity disorder, and allergies. Measurements that are useful for sodium benzoate are quantitative nuclear magnetic resonance, QNMR, high performance liquid chromatography, UV vis spectrophotometry, and liquid chromatography mass spec. To teach a lesson about sodium benzoate, a couple of things come to mind. First, students could be assigned an experimental design lab. I would teach the lesson very similar to what we had to do for this class, in that they could either choose their own, or possibly I would give a short list of different chemicals that could be researched. But if I were to specifically give them sodium benzoate, I would have them follow very similar properties and research that we had to do for this project. But in addition, I would give them either an open-ended experimental design lab activity where they could test the effectiveness of sodium benzoate as a preservative. I could give them some prompts along the way. However, this would very much be experimental design where they would have to come up with and test whatever properties they wanted. A couple of hints that I would give them, again, if I specifically gave them sodium benzoate, would be that they could either design a lab that tests the effectiveness as a preservative at certain concentrations of sodium benzoate, or design a lab that tests the effectiveness as a preservative at certain pH levels. We see that sodium benzoate is very effective at lower pHs, but the higher pHs, sometimes sodium benzoate is not a very good preservative. Another possibility for teaching about sodium benzoate as a preservative could come from a lab very similar to Aslam and others from 2017, where they tested the effectiveness of sodium benzoate in fruit juices and squashes. They took commercially prepared fruit juices and they analyzed the fruit juices using high-performance liquid chromatography methods to test and see the levels of sodium benzoate that were present. First, they wanted to make sure that the levels were within the ranges that were acceptable according to the U.S. Food and Drug Administration and other authorities throughout the world. In their research, it's good to know that all of the juices that they tested were in acceptable ranges of concentrations. Now, in order to be able to do this lab, they would have to probably be in a more advanced class, probably at the collegiate level. We would not be able to use HPLC or ultraviolet diode detection to test for sodium benzoate because most high school labs are not equipped as such. So I feel that this is probably more of a, maybe like a second or third year chemistry class at the collegiate level. The instrumentation would be available at that point. I do have several references from which I followed in order to come up with the presentation and also with the paper that was submitted. It was determined through the research that sodium benzoate is not particularly toxic to humans unless at high concentrations, and it does not accumulate, so therefore does not pose a huge environmental threat. However, when sodium benzoate is mixed with other chemicals such as vitamin C, benzene could be produced with the aromatic ring that's attached, and then toxic situations are possible. Thank you for listening to my presentation.